Hello, everyone. Next slide. My name is Giuseppe. I go by G for my American friends. I'm based in Milan, Italy, and I will just spend a few minutes for introducing Akamas and then pass the ball to my colleague, Luca. Luca, can you please introduce yourself?
Hello, my name is Luca. I'm also Italian, but I've recently moved to Boston, and in this session, I will provide you a demo of Akamas applied to a banking application.
Great, thank you, Luca. So next slide. As we heard from Joseph, every company in every market segment aims at delivering high quality services at minimum cost, while also improving their business agility and operational efficiency. However, performance engineers are facing today some major obstacles and blockers that prevents them from effectively supporting their business goals. In addition to growing architectural complexity, think about microservices, Kubernetes, faster delivery rates, DevOps practices, brand new technologies and skill shortage. There are three factors, maybe less known, that I would like to focus on here. Well, the first one is the explosion of configuration parameters. Today, a JVM has 800 parameters, MySQL more than 500, AWS added more than 100 EC2 instance types a year. So the number of parameters and the combinatory of those parameters is exploding. Second point, every time you get a new release of the same technology you've been using, until the day before, well, you can expect some very different behavior in your environment. So think about the impact of the latest JVM garbage collector on your application and workload. And third, you cannot simply rely on best practices or default values. You may know Spark defaults, for example, are not suitable for a production environment. And you may find that there are some counterintuitive or even negative effect. So a database throughput might be decreased in terms of the throughput might be decreased, even if you add more memory. And if you reduce the memory, well, then the throughput may increase. So very strange behaviors. In conclusion, performance matters more than ever. But unfortunately, the challenge of properly tuning IT stacks has become very, very difficult and beyond the reach of even the most experienced performance tuning experts. So Akamas was designed exactly for the goal of addressing this challenge by leveraging 20 years in experience, performance tuning, load testing, capacity planning. Our solution was designed with four major requirements, four pillars in mind. The very first one, the ability to optimize any environment, any system, all layers from application, middleware, databases, you name it. Second point, the ability to smartly explore this huge combinatory space of combination of all the parameters, right? So this can all be done by adopting patented AI, which we have specifically designed and implemented, that allow us to converge to an optimal configuration with few experiments, typically in a very short time, hours. I'm talking about just hours, which is definitely out of the possibility for a human performance expert. Third, the system can be tuned and optimized according to your specific goals. You can define goals that will translate your specific goals in terms of reducing the cost or improving the performance, or a combination of multiple goals. And you can also specify technical and business constraints, such as not increasing the error rate or keeping the response time to a given level. And finally, as you will see in action in a few minutes, the full approach is completely automated by specifying custom workflows that can be defined in terms of how to collect the metrics, how to apply the changes, how to also load the system with a specific workload of interest. Well, I think it's time for seeing Akamas in action. Luca, the floor is yours. Thank you.
Thank you, Giuseppe. So today I'm gonna guide you through a demo of Akamas. and I'm going to show you how we have been able to optimize a payment manager application. The optimization goal was to maximize the throughput of the application, meaning the requests per second that the application was able to manage, ensuring that both response time and error rate were below a specified threshold, usually SLO, so service level objective for this kind of metrics. Before showing you the Akamas UI, just a quick overview of the scenario of the demo. So Akamas, during an optimization, performs several experiments. An experiment is an assessment of a different configuration. So what you are seeing right now is the process that happens during each and every experiment. So the first step of an experiment is to apply the configuration to the target system. In our demo scenario, we did that through an SSH connection to the payment manager nodes. The second step is to generate a workload on the target application. And in the demo, we did that with the JMeter. We support many other tools, but in the demo, we use JMeter. The third step is to collect KPI from the target system to validate and assess the configuration that we applied in the first step. And in the demo, we did that with Dynatrace. So a Dynatrace agent was running on each and every node of the payment manager application. The fourth step is to compute a score and to evaluate the configuration that has been applied in the first step. In our demo, the goal was to increase the transaction per second, the throughput of the application. So the score has been measured, the score of each configuration has been measured in terms of transaction per second. The last step of each experiment is the actual optimization, where the machine learning algorithm that Giuseppe mentioned before kicks in. So Akamas is able to identify the most promising configuration based on the score of the previous tested and assessed configuration is able to identify the most promising, and a new experiment starts where the configuration is applied, the workload is generated, the KPI are collected, and a new score is computed. So let's move to the Akamas UI. Sorry for that. Okay, here we are. So before showing you the result of the optimization, the payment manager, let me briefly introduce the target, the system that we optimize, so the payment manager application. In Akamas, we model the target of an optimization through components. As you can see, for the payment manager application, we had 3 components. One was the JVM powering the application server. One was the Oracle database, and the third one is the web application, a component that we use to model the end-to-end metrics exposed to the customer, the user of the payment manager application. As you can see in the JVM Oracle, we had metrics and parameters. So let me show you a bit of detail about that. It's a JVM component, meaning that out of the box, Akamas can provides you all the relevant parameter and metrics for a technology. As you can see, for the parameters, we provide you the possible value, the domain of possible value, which is the default, and also a bit of information on the role of the parameter in the optimization. All this information is shipped in optimization pack. I will provide you a bit more information about that later on in the demo. Let me focus for a bit on the properties. As you can see in the properties area, we have this Dynatrace section where we have the unique identifier of the JVM that we were monitoring during the demo. This is the unique identifier that we use to match the Akamas component to the Dynatrace object within your Dynatrace installation. Coming back to the system, last step, or again related to the Dynatrace integration, is the telemetry instance. The telemetry instance are the object that we use to collect information. As you can see here, we have a Dynatrace telemetry instance. And those are the only information that we need to be able to connect to a Dynatrace server. So the URL of your Dynatrace installation and the token that Akamas will use to connect through the API to Dynatrace. So URL, token, and unique identifier. With those three elements, Akamas is able to collect all the metrics needed to operate, integrate with Dynatrace. But let's move to the optimization. So the payment manager optimization. This is the summary page, the landing page of an optimization study, as we call them in Akamas. As you can see here, we have the goal: maximize the application transaction throughput. And just providing you a bit more of detail, in Akamas, you can define a goal that can be either maximize or minimize a function. So in this case, we optimized the transaction throughput, so a single metrics, but we are allowed to define even complex goal where you can combine different metrics that can be provided by the telemetry provider, for instance, Dynatrace. And the bottom section of this tab, you can see the constraints. We allow to define two main kinds of constraints. The first one are constraints relative to the baseline. So the first experiment that we execute during a study is the measure of the behavior of the system with the default configuration. We call this experiment baseline. So with the constraints related to the baseline, we simply ask to Akamas to have constraints based on what has been measured in the baseline. In this specific case, we specify to Akamas to accept an error rate that has to be equal to the error rate that we had in baseline. Another kind of constraints that can be used, for instance, to implement service level objective in Akamas is the absolute constraints. In the absolute constraints, you can specify a specific threshold, a specific value for a threshold. In this case, the transaction response time has to be lower than 300 milliseconds. So any configuration that lead to an increase in the transaction response time will be not considered valid by Akamas during the optimization. In this section, we have a summary of the parameters. In the system that I showed you before, we have both JVM and Oracle component, but in this specific optimization, we focus just on the Java layer. This because we knew that the JVM of the system was running with the default configuration, meaning that just few of the hundreds of parameters were specified. And by experience, we know that there is a huge optimization space when you run on your default. So we focus just on the Java layer for the optimization, the payment manager application. So 20 parameters coming from the Java layer. On the best core section, you can see the starting point of the optimization. So the baseline that I mentioned before, at the beginning of the optimization, the application was able to manage up to almost 29 transactions per second, while after the optimization, the same application, the same hardware was able to manage up to 35 transactions per second. So acting on those 20 parameters, Akamas was able to identify a configuration that increased the throughput of the application of 20%. In the bottom part, you can actually see the value of the different parameters. So in this section, we're going to have a look only to the most relevant, so not all the 20 parameters, just a subset, the most relevant, as I said before. And for each of these parameters, you can see the baseline value. This means that this parameter was not configured in the baseline. You can see the best value. So the value that actually allow Akamas to achieve the 20% improvement with respect to the baseline. So these are the value that you have to configure on your JVM to be able to achieve the improvement. And then also the relevance index, that it's an index that we provide that allow to understand how impactful a specific parameter has been with respect to the optimization. So this is the summary tab of a study. Let's move to the following one. As we said before, Akamas performed several experiments. In this specific case, in this page, you can see all the experiments that have been performed, and you are also able to see the actual value that have been tested in each experiment. So for instance, this is the first experiment. Opening this tab, you can see which were the value for each of the parameters, the 20 parameters that were in the scope of the optimization. You can also export those parameters in a quite easy way with this button, CSV button. As you can see, many experiments, some of them show an improvement, some of them, especially at the beginning of optimization, can show not even a lower transaction per second throughput with respect to the baseline. This because at the beginning, Akamas has no information about the system that is optimizing, but performing experiments start to collect additional information about the system itself. So his knowledge of the system, of how the parameters are affecting the system, increase experiment by experiment, leading to the optimization over time. Let's move to another tab. So the analysis one. In the analysis, we see how the optimization worked over time. So each dot is a different experiment. And for each experiment, we collect many information. This tab is really useful, this table. We use it to do analysis after the execution of an optimization study, because performing several experiments, testing many different configurations and collecting many metrics, we have a lot of information of the system. Akamas focus and works towards the goal that has been defined. So in this specific case, Akamas look for an optimization, a configuration that allows to maximize the transaction per second. But as I said before, we executed many experiments. So we can dig in this huge amount of data of information to find other relevant configuration, what we call the side goal. So for instance, we can sort all the results for each of the metrics that we had. In this case, we can assume, for instance, that we have the need at data center level to have smaller JVM. So reduce, for instance, the footprint of our servers. So we can look if we have configuration that allow us to reduce the memory used by the JVM. And browsing the data, maybe I can add a bit more overall. We can find, for this configuration, experiment 175, where Akamas was still able to identify a better configuration with respect to the transaction per second. So we have an improvement of almost 10%, but reducing of almost 55% the heap size. So these are the kind of goal, the kind of configuration that you can find looking at the data in this table. Last tab that I'm going to show you is the metric one. So in the metric tab, we show you the behavior of the metrics over time. It's an easy way to compare different experiments. By default, Akamas shows the baseline experiment and the best experiment and show the most relevant metric. In this case, the throughput, the error rate, and response time. So also the metric where we define the constraints. But let's focus on the throughput. So as you can see, the blue line is the baseline. So the behavior of the throughput at the beginning and with the original configuration, and the red line is the best configuration. And the windows allow us to understand which was the last part of each test that satisfied all the constraints that we defined. As you can see, in the baseline, the throughput was 28.8, as you saw at the beginning, while in the best configuration, we were able to reach almost 35 transactions per second. So the metrics allow this nice comparison. Last piece of the demo, and then I will pass back the information to Giuseppe, are the optimization pack. I briefly talked about them at the beginning. Within the optimization pack, we provide all our knowledge about the technology. So those are provided out of the box by Akamas, and the idea behind an optimization pack is allow our customer to optimize a system without being an expert, without spending days or weeks in the documentation of a product or internet, or even hiring a subject matter expert, because all the information needed to optimize technology are within an optimization pack. For instance, on Oracle, we support many technologies, many versions of this database. And as you can see, for each of them, huge amount of parameter and metrics. And I'd say that that's all from my side. So Giuseppe, feel free to.
Thank you, Luca. If we go back to the deck, I've been answering some of the questions that were coming up on the chat. Hopefully this was providing the expected answer. There were a couple of information that, if time allows, I would like to provide. One is, what might be your next step? First of all, there are plenty of resources that you can look at on our website. I provided also the link in the chat window. And specifically for related to the topic of today's event, there's an interesting case study from applying Akamas to a banking application. Second, I would definitely recommend going to Gartner Peer Insight. There are a couple of interesting stories provided by our customers. You can read the benefits. We honored to receive full marks by our customers. So hopefully you would get the same experience. Very interested for us to get started and extend Akamas to your specific environments. Every week we learn something. Have a look also on our YouTube channel. We are recording every week some interesting case, most recently on Dataproc and Lambda. And finally, we do have a free trial initiative, so we're very welcome to join us there. And if I have one more minute, there's a backup slide that I wanted to show, which is about the degree of coverage we can provide. Those are just some logos, but definitely in terms of being able to manage, as Luca was showing, a multitude of different technologies. Yeah, there are many more than that. And in terms of the ability to leverage telemetry providers, from Dynatrace to open source tools, and even the ability to leverage an InfluxDB or a CSV file. Yes, we do have options that you can leverage for making sure that Akamas can fit your environment. Thank you again.